I'd like to talk about sandstone. I'd like to talk about how sandstone is created, how you can identify it, what the consequences of sandstone is for the ecology and the agricultural system. Now, quartz is one of the commonest minerals, and it's exceedingly hard. And because it is hard, that explains why it is so common. Other minerals often erode away or dissolve away, but quartz tends to persist, which makes it really common. So sandstone is created when you'll have an area of sand, it could be a beach or a bit of desert, and then the layers accumulate. So it's a sedimentary rock. You can see these layers here. Sedimentary rocks form in layers, and then other rocks will form on top of this and push this down and compress the grains, and then water will enter between the different grains and chemical reactions will fuse those grains together, the sort of concrete fusing of the grains, and that's a process called lithification, the creation of rocks. And as it's a sedimentary rock, you can see these bedding planes. It makes it a great material for building. So you can cut through those bedding planes. And this is what Stonehenge is made of. This is what the Orkney Neolithic monuments is made of. And you can see around here, the buildings are often of this sandstone. Often they have this lovely orangey colour from the iron oxide that occurs. So how do we know this is sandstone? Well, it's kind of easy. There's, you can see the sand particles, and if you rub your finger across it, it feels rather like sandpaper. And it's hard, so if you try cutting it, you see that it doesn't cut. If this was a limestone, it would scratch, and if you try rubbing, it actually scratches the steel blade. So the fact it's a sedimentary rock and it's made of sandstone, it's made of sand, makes it clear this is sandstone. Now, how was this created? So the sand here could come from a delta or a desert or beaches or a river system or lake system. How might this be created? Well, you can look at the evidence. Ideally, you'd find some fossils in here that would give it away, but normally you don't. But you can look at other bits of evidence. So if you look here, you can see these pebbles here, which are irregularly shaped. If this came from a beach, which had been rolled around, then these would be round. And then geologists talk about a process of sorting. So again, go on a beach and you'll have sandy beaches, and then you have another area which will be shingle, another area will be pebbles. So it is well sorted, the different particles in different areas. Now have a look here, and this is badly sorted. So you can see these pebbles here, but then there are larger sand particles here and smaller sand particles here. So this is poorly sorted rock. And then look at the structures. You can see here there's a series of horizontal layers, but then come up here and everything changes and the layers are at an angle. So it is clear that there's been a change in the direction of the currents. So this is fresh material. This has been poorly sorted, all mixed up. It's got currents that go in different directions. So geologists know that this is a braided river. So a braided river is a river that changes direction over time. And this was thought to be one huge, great braided river system, which then created this sandstone. And I'm not a geologist, I'm an ecologist. And I actually find it really satisfying. I've never been here before, but I knew what the answer was. But there's enough evidence here to work out what is going on. You can work out just by looking at this what this system was. So what are the consequences of sandstone for the surrounding environment? So it's a hard rock, and so it erodes poorly, and so it produces very thin soils, and it's acidic, so it's not great growing conditions. But there are various characteristic plants you get in acidic soils. So particularly there's heather up here, and then there's bell heather, or there's bilberry, or there's sheep sorrel here. These are all characteristic plants of acid conditions. Now this sandstone rock is important as an aquifer. It stores water. So water will come in through the cracks, and it will come in and fill the gaps between these grains. And here in Northumberland, it's extremely important supply of water. But curiously, you would then think that this landscape would be dry, and often that isn't the case. Why is that? Well, let's have a look at how the soils are created. So as you said earlier, the soils are thin. There's not that much vegetation growing here. But as the plants decay, they produce humic acids. And when they leach into the soil, they leach out the aluminium and the iron. And then that produces this characteristic grey soil. This is called a podsol. But then lower down, the iron may then come out and form an iron pan, and that can then act as a waterproof layer lower down. And that can then mean that this area can be waterlogged. And that means you then get species such as soft rush growing here. And that occurs because the iron pan underneath means that the area is waterlogged and wet. And if you look at the landscape here, you can see that this whole area here is wet with soft rush, and this would be what much of this area would traditionally look like. So what's this like as an agricultural system? Well, over here, this upland system, poor, thin soils, very acidic, and this is usually used for extensive sheep grazing and not great growing conditions. If you look over here, so the farmers tend to do things about this. So over here, where those cattle are, you can see that that's been drained in order to make it better grazing. And then over here, you can see this is those fields there, or what this system would traditionally look like. But over here, it's clearly been drained, and then lime's been added to increase the pH, so it's no longer acidic, and it's been fertilized, and you have these much brighter green fields and greatly improved grazing conditions. And also these valley systems may well have runoff coming from the uplands and have sometimes glacial material. And further over there, you could see that there's arable. I'm sure there's improved soils over there. So sandstone, because it is so hard, produces these dramatic landscapes. Many of the upland landscapes we know are sandstones because they're so hard, and they can be very striking areas. But what are the consequences for the river systems? We're sitting on a great block of sandstone, which you can see emerging in the distance over there. And this acts as a huge sponge, much as limestone does, and that means when there's heavy rainfall, it's absorbed and there are fewer floods. It means that at times of drought, rather like now in the summer of 2026, then the river still keeps flowing because it's coming out of the rocks underneath. And limestone produces calcium carbonate. That means there's material for mollusks to build their shells and shrimps to have their cuticles. And when you have acid rivers like this, then you tend not to have freshwater shrimps. You tend not to have many snails. And it's acid, and as it's acid, it dissolves the aluminium, and then that aluminium can be toxic. It's particularly toxic to mayflies. So you get lots of stoneflies in these acid rivers, but not as many mayflies. And it's infertile. There's very little nutrients in the sandstone rocks. So this river here, there's not many aquatic plants in there. It's a pretty infertile environment. So the water comes through the rocks here, but it doesn't really clean it and filter it as it goes through. So it just comes out. So pollutants will end up coming out into the rivers. But in sandstone areas, the soil is often so poor and the conditions are so poor that often there isn't intensive agriculture. So looking around, there's some fields up there. You can see there's obviously nutrients is being applied, but there are many fields here which are fairly unmanaged. So there isn't the intensity of agriculture and the runoff that there would be in many areas. And then because it is sandstone, it's hilly, and that means there's a steep slope. So these rivers are fast flowing. There's sand and gravel that's come out of the sandstone. And so these areas are very good for trout. They're clear because they're low fertility, sandy gravels for them to produce their eggs, lay their eggs in, and stoneflies and other species. So I've just seen some fish rising there. I can see there's quite a few there. So this is classic salmon and trout habitat. So the basic geology really affects the whole river system.